Hi, super scientists. Today we are talking about the 2.2 notes, floating and sinking. And this is on page 5 of your freshwater packet. And, I'm pretty sure everybody knows what floating and sinking is, but there might be a few new words here. The forces that are acting upon an object in water specifically might be new to you. So let's get started here. Buoyancy is the ability to float. So if something is buoyant or has high buoyancy, it's going to be able to float. The buoyant force is the upward force exerted on an object underwater. It acts opposite the force of gravity and makes objects feel lighter. When you go swimming, you may feel lighter. You should. Kind of like this scuba diver down here. As the scuba diver is swimming, they don't feel as heavy as they do if they were standing on the ground. They should feel a little bit lighter due to this buoyant force. And then we have this animation over to the side, and it is going a little bit quickly, but it's talking about the weight of the ship. And the weight of the ship is that force is going downward. And then you have the buoyant force. An arrow coming up right here in black is the buoyant force, and it's an upward force that's helping this ship or this boat float. All right, and then it says that the shaded region is the amount of water displaced. So my next slide here explains what that means. All right, so Archimedes' principle is talking about that water that is displaced. So let's say that I take, a toy boat and I put it in the bathtub. When I place that boat into the bathtub, some water is going to be displaced, or it's going to rise a little bit. And you can see the boat kind of going back and forth. If we put a boat in the, a lake, the same thing's going to happen. We can't really tell though, right? So Archimedes' principle says that the buoyant force acting on a submerged object is equal to the weight of the water the object displaces. And this diagram down here does a good job of saying what that means. So in this diagram, the water originally was at this pink dotted line, and then they put the wood block in. And when they put the wood block into the cup here, the water rose this amount. So it rose from the pink line to the top of where it's at right now. And that's what is called displaced water. Well, the weight of that, just that much water all the way across, is equal to the buoyant force that's acting on the submerged object. So remember that buoyant force is kind of an upward force, and it is equal. So we can measure the weight of this displaced water and know how much buoyant force is acting on that object. We also have what's called density, and you've heard of density. We've talked about it already this year. Density is mass divided by volume, and if an object floats, it's going to be less dense than water. If it sinks, then it means that it's more dense than water. But we can also be talking about air. So for instance, Pooh Bear here, he has a balloon that's floating. So it's probably filled with helium. And the helium is less dense than the air around it, so the air outside the balloon. And so the balloon then floats. So we could be talking about air, we could be talking about water. This example is water, right? So we have wood is less dense than water, so it floats. This rock is more dense than water, so it sinks. And so every object, all gas, things like that, all have a density number. And so that's going to help us know if something's going to sink or float. We are concerned more with water in this unit, and so we need to just kind of memorize that the density of water is 1 gram per cubic centimeter. So real easy number to remember for you. Density of water is 1. All right, so if an object has a density that is less than 1, it's going to float in water. If an object has a density that's higher than 1, So even 1.002, it can be a decimal. If it has a greater density, then the object is going to sink. What kind of numbers are less than 1 are going to tell us that we are floating? Think about that. What kind of numbers are less than 1? Fractions and decimals. Good. So we're looking at things that might be, you know, 0.8 grams per cubic centimeter or something like that. So a decimal or, you know, 3/4, any kind of fraction. So those kind of things are going to float in the water, whereas greater numbers than 1 are going to sink in the water. All right, and just going back to this slide really quickly, guys, one misconception with density is that the bigger the object, the more it's going to sink, right? So if we have something really large and we put it into our cup or our fish tank or whatever we might have, that it's going to automatically sink. And that is not true, okay? Because we're dividing the mass divided by the volume, let's take a specific kind of wood, for instance, birch wood. Birch wood, no matter how big the piece is, because we're dividing by mass divided by volume, birch wood is always going to have the same density no matter how big the piece of wood. So if birch floats, it's always going to float whether it's a big or a small piece. So that's a huge misconception that when we have a bigger piece of something, it's going to then sink, which is not true. It doesn't matter how big the object is, it matters whether its density, when we divide, is higher or lower than 1, like we said on this slide. All right, and that finishes up our notes. You are going to do a little lab demonstration with your teacher. And that is the table that's right below our notes here that says, will it sink or float? So you're going to see some objects and be able to kind of guess whether they're going to be able to sink or float. So have fun with that.